Major support for Do the Math has been provided by Chevron, the Kern County Superintendent of Schools, California Resources Corporation, Kern County Water Agency, Kern Schools Federal Credit Union, Panama Buena Vista Union School District, and Bakersfield City School District, with additional production assistance provided by these supporters of education in Kern County and throughout the state of California.
Well, good afternoon and welcome to Do the Math. I'm Michael.
And I'm Chuck. Our phone tutors are standing by to take your calls. If you have math questions, you can call here in Bakersfield at 636-4357. San Luis Obispo and the outlying areas, you can call toll free at 1-866-636-6284. You can send us questions by email at dothemath@kern.org. You can watch the show live online at dothemathonline.net. And you can look for us on social media, Facebook, Instagram, Twitter, and YouTube.
All right, you know what? A lot of ways to get a hold of us. You brought up the email, and I know we mentioned something about that yesterday. And I know in the control room, Mackenzie's probably back there. Correct me if I'm mistaken, but I think Samantha sent us an email and had a math question.
Okay.
But there wasn't a math question on it. So I think maybe she tried to attach something possibly. So
Got
Samantha, if you're watching the program live right now on Wednesday, September 30th, go ahead and give us a call. We'll go ahead and work on that. If not, you can go ahead and email it to us and we'll see if we can get to it during the program. If not, we'll go ahead and help you out with that once the program is through. Or perhaps we'll have one of the phone tutors, if they have a moment, they can work on it while they're in there on the phone as well. So you can always email a question. Sometimes students are, you know, I'm working on this at night. I've got a couple of days I can work on it. I'm not going to be able to watch the program or call live. Boom, I'll just send it in, and then we'll take care of it like that. A couple of very special guests in studio, and yesterday, Mackenzie, Marty, and John were out at the Kern County Fair, and we had an opportunity to see some of the activities that were going on out there.
Looks like they were having a great time.
I believe they were.
Yes.
And I went out there, and they were all like, all right, we're wrapping up and we're going to put everything else in. But they still had, oh, and that's right. While we were out at the fair, Lewis and Marie were walking around. And Lewis decided, he's like, are you the guy on math? Why do you ask? So he just wanted to say how much he enjoyed the program. He, as an adult, views the program as many other adults do. They kind of flip around and are like, yeah, it's a pretty cool show. We like kind of what you guys are talking about. We want to do the problems faster than you guys do them, which is fine because we want to get the kids through them and make sure they understand them. But they were concerned about things that their pre-K grandchild, I believe, could do to get them accelerated and into math a little bit more. Loves doing math and things like that. Just recognizing patterns. Is a big one, I think, for kids in pre-K.
Right.
I mean, they can take anything, any objects at all, kind of add, subtract a little bit, but like looking at attributes and looking at patterns also to kind of get that different thinking in it.
Oh, yeah.
So anyway, Lewis and Marie, I know you guys are going to be watching the program at some point, so hello and thanks for stopping to see us at the Kern County Fair last night. Before we get to our first phone call of the afternoon, though, let's first take a look at today's Math in the News. And this, fresh out of the newspaper this past Sunday, one of the advertisements, and we'll go ahead and I'm just going to kind of hold it up over there. We'll see if Trey can get that on camera 3 right there. Save up to 70%. How many of these advertisements do you see on a daily basis with something big like that?
Yes.
They're out all over the place.
All the time,
right?
all the time.
It's not, I mean, every time you open something, it's not just information, it's something flashy and it's right there, which is what it's supposed to do.
Right.
So I figured, you know what, we see this all the time. Let's tie it into a little bit of math right now. So on the screen we can see some other hot price, special offer, best price guarantee, special promotions, all of these little things that attract your attention, get your eye, so that you look at that a little bit more. So let's tie a little bit of math into all of these. A percent, and we talk about percents, decimals, and fractions a lot on the program because that's one of the things that when students are in 4th, 5th, 6th grade, they're working on a lot. And if they get that base, 7th and 8th grade will be a little bit easier for them as well.
Right.
So we know a percent is a ratio that compares the number to 100. So first we want to express 0.327 as a percent. So we know that we need to move the decimal 2 places because it is out of 100. So we can represent that as 32.7%. Now we want to take a percent, write it as a decimal. So we're going to move the decimal 2 places to the left. So we have 0.068. So we know that it's 6.8%. Write 64% as a fraction, but in simplest form. So we need to know that 64 would go over 100. But then if we simplify that, we get 32 over 50. We can simplify that even more, but just to see the process of doing that.
Right.
So that's that screen on that. So how we can tie a little bit, because we saw percent.
Percent.
So it's like, all right, let's take a look at percents and dive into them a little bit
You see them
more.
all the time.
All over the place. So percent equations. So these are some of the equations that students will see as they're going through school, whatever grade level they're at. Finding the percent. What percent of 50 is 6? So when we write out that equation, what percent of, we know is mathematical for multiplication.
Right.
So what percent of 50 is the equal sign, 6. So just looking at what they're asking you, you can set up the equation that you need to do.
And the little star, the asterisk, is from the computer because a lot of times multiplication is just a dot or an X. But the little
And
star
I could have put a
shows
lowercase x in there, but then somebody might, is it NX50 or something like that. But and also nice for the students to see there are a multitude of ways to represent multiplication.
Right.
Finding the part. So what is 25% of 40? So here once again our unknown, what is the equal sign, 25%. Easier to work with decimals. So what is 25% of 40? So once again, simply knowing the terms, because a lot of times students will see a question and they're like, well, I'm not sure how to set it up.
Right.
Follow right along, and it's a little bit easier like that.
And that problem is, it's written as an equation, but it's just a simple multiplication problem.
Right, you just go and 0.25 times 40, and you're all done. All right. Finding the whole. 6 is 35% of what? So once again, we have 6 is 35% written out as decimal of, and then our unknown what. All right. So that is today's Math in the News. Figured we'd take a little bit of percent and tie it in with the advertisement that we saw right there. 636-4357 is the phone number. We do have phone tutors available on Tuesdays and Wednesdays between 3:30 and 5:30. As a reminder, every time you phone in and we do one of your math problems on TV, your name is entered into a drawing, and that drawing every single day is for a family 4-pack to go see the Bakersfield Condors. Right now we're going to go to the phones, and I guess Nathan is not ready. I know he was ready because I spoke to him a little while ago, and we'll see if Nathan, we're trying to get him back on there right now. I know that he's working with expressions.
Yes.
And a lot of students have been phoning in with that right now because in order for students to move into equations a little easier, expressions comes first.
Right.
So right now we've got Nathan online, a student from Ronald Reagan Elementary. Nathan, how are you today?
I'm doing well.
And you're in 6th grade, correct?
Yes.
All right. Nathan, as soon as you're ready, let's hear the math problem that you're working on.
Huh?
As soon as you're ready, you can read the problem.
Okay. It is 3x plus x, then in parentheses, 5 minus 2x.
5 minus 2x, did you say?
Yes.
So this x is in front of the parentheses. Do you see what I have written down here? Is it
Yes.
3x plus x and then open parentheses, 5 minus 2x and then close parentheses?
Yes, it's the equation.
Okay, so there's my expression, and all you're going to do here is simplify, right? That's your instructions. So what do we do first to simplify this expression?
Yes.
What are we going to do first?
We're going to multiply the x by the 5.
Okay, so this means when that x is in front of the parentheses, it means multiplication, doesn't it? So we're going to multiply the x times the 5, and then what?
And then we're going to multiply the x by the 2x.
Right, so we're going to get rid of those parentheses, aren't we? That's the first step in simplifying. So I've lost my...
Yeah, well, we can see Samantha emailed back to us right there.
Yeah.
So that's good. Let me minimize that for you there.
There you go.
There we go.
So we're going to remove the parentheses by multiplying, and that's the distributive property, isn't it? Then once we do that, we can combine like terms. So let's go ahead and do that multiplication. We're going to leave the 3x the way it is. And here we're going to get x times 5. Now I could write it as x times 5, but how do we normally write it?
We write it 1x times 5.
Yeah, so but x times 5, we'll write it just like we wrote this term, right? We'll write it as 5x. So x times 5 is the same as 5 times x, and we don't need the multiplication sign, do we? Then we're going to subtract this answer, and we're going to go x times 2x. Now, what's x times 2x?
2x.
So we got a 2 there, and then what's x times x?
X times x is...
So what's x times x?
I do not know.
Okay, we know that x plus x is 2x, but x plus x is 2x, but x times x is going to be x raised to the second power, right? We're going to use an exponent to show the number of factors, the number of x's we have, and that's x squared. So this is going to be 2x squared, okay?
Okay.
So now, instead of having all of this with the parentheses, now we have simply 3 terms, a 3x, a 5x, and a minus 2x squared. Now we're going to combine terms, right?
Yeah.
And we can only combine like terms, so which terms up here are like terms?
The 3x and 2x.
So the 3x, but which one has the same variable with the same exponent?
The 5x.
Yeah, we have a 3x, we have a 5x. This has got an x, but notice it's an x squared, so this is not like these other 2 terms, is it? So these we can combine, this one we can't. So what's 3x plus 5x?
Huh?
What's 3x plus 5x?
That'll be 8x.
So that's 8x, and that minus 2x squared stays by itself. And so there is our expression simplified.
All right,
8x
Nathan, you
minus
still
2x
online
squared.
with us? Nathan, you still there?
Yeah.
All right, because I noticed that you had a little bit of difficulty with the x squared.
X squared, yes.
So-
Exponents.
Erase the problem up there for me, if you would, please. Nathan, you are the lucky recipient today of a bonus problem that you have no idea what it is. You ready?
Okay, so let's work through a new one.
I hope he's ready. Okay, here we go. It's going to be similar to the one you just did, but it's got something where you're going to be using a square again, okay? So a negative sign and then open parentheses. 6n minus 3, close parentheses, plus 7n, open parentheses, n plus 8.
N plus 8. All right, so Nathan, we're going to do the same thing, right? We're going to remove parentheses, so help me work through this problem, okay? We're going to use the same property we just used, the distributive property, and first we're going to get rid of these parentheses with that negative sign in front, right?
Yeah.
And then we're going to remove these parentheses, right, using the distributive property here. So let's do this one first. So I'm going to distribute negative. Now I can think of this as a -1, can't I? That negative out in front is like a -1 that we're multiplying by. So let's multiply -1 times 6n. What do you get?
Negative 6n.
Yeah, so it just changes the sign, doesn't it? And then I'm going to get -1 times -3. What's negative times negative?
Positive.
So that's going to be positive, And 1 times 3 is just 3, isn't it?
Yes.
Now I'm going to come to this one, and I'm going to have 7n times n. So now, again, what's 7n times n?
7n times n would equal 7n squared.
So 7n to the second power, 7n squared, right?
Yes.
Plus, now what's 7n times 8?
7n times 8 will equal 56n.
56n. All right, so again, we've used the distributive property twice. We've gotten rid of the parentheses. Now we look for like terms. So let's start with this first one. We have a 6n. Any other like terms with that 6n? Negative 6n. So we got 3 here, no n. We got an n squared. It's got an exponent. And here we have a
7n.
56n, right? So the 7n has an exponent, but the 56n doesn't, does it?
Yes.
So we've got 2 like terms here of a negative 6n plus 56n. What's negative 6n plus 56n?
It would equal negative 50n.
Well, let's see, this is positive 56, right?
Oh, I mean, positive 50n.
Yeah, minus 6n, so that's going to be 56 minus 6, that's going to be positive 50n. Now, do we have any other numbers to go along with the 3?
No.
Nope. Do we have any other n squared terms to go along with the 7n squared?
No.
Nope. So I could write my answer as 50n plus 3 plus 7n squared, but normally when we do a problem like this, we're going to put the highest power of the variable first. So even though technically this is the correct terms, let's write it in order. Put the 7n squared first. Then we'll put the 50n, because that's n to the first power. And then 3, there's no n. And that'll be the answer to that problem. Very similar to the problem that you had.
Nicely done. I'm glad you did that one, Nathan, and you were able to say n squared with that 7n squared on his own without
Right.
us having to tell him. So, Nathan, congratulations for doing that problem. And since you did a nice job on that, we're going to send you out to the Kern County Fair. So you've got a couple of days left to go and check out all the festivities out there.
And the animals.
That's part of the festivities.
And the food.
And the food. How could you miss that? Anyway, we were there. We saw a calf, a couple days old.
Oh, yeah?
Yeah. So I think it was only one time I've been lucky enough to see the actual birthing. But this, and it was just struggling to stand and things like that. Anyway, Nathan has also got himself entered into a drawing for a family 4-pack to go see the Bakersfield Condors. With us today, the goalie, the right wing, everybody. No, I'm only kidding. How are you today?
I'm just a radio guy.
So with us today, we've got Ryan Holt in with us, and let everybody know your position with the Condors.
I'm the Director of Broadcasting and Media Relations, so anything from our social media and our radio broadcast is in my realm. I also do a lot of our video work and on the digital side of things, so
Okay.
kind of got my hand in a lot of different places. So
Now, how long have
it's
you
fast.
been with the Condors?
This is my 5th season now, so it's I came out here not expecting to be out here very long, and here I am 5
You're
years
here.
later. So, and
Well, you
I
know
love
what?
Bakersfield.
I said the same thing many moons before that too. And so anyway, from where?
I'm from Boston, Massachusetts,
Okay.
so I
Well-
moved across the country.
Some people have to be from Boston.
Yep,
I'm
some
sorry.
people.
You know, when I saw your phone call and I saw the Boston on, I was like, I don't know if I need to pick that up or not. But anyway, I was a little close to you in New York and
Yeah.
moved out. I think we had a discussion about this
I
last
think
time
so
you were
too.
on.
Yeah.
We'll let that go right now. So the Condors are new affiliates. Talk a little bit about that.
Yeah, we changed leagues it was late in the year last year, but over the summer was when the real work began. So we're in the American Hockey League now, and for fans that might not know the ladder system, I guess, in hockey, the American Hockey League is essentially AAA
Right.
in the baseball realm, if you will, and most fans out here are familiar with baseball. It's one step away from the National Hockey League. So A lot of fans out here in California are fans of the Kings, fans of the Sharks. Well, our team is the Oilers. They're up in Edmonton, up in Canada. But they're going to play the Kings and the Sharks and the Ducks. They're going to play them often. And that's what's going to happen with us as well. We're going to play San Diego and San Jose and Ontario and Stockton. We're going to play these teams a lot. And, it's very interesting, and we've made a lot of renovations to the arena, but you're going to see players that have never come to Bakersfield before. And then the next night, they're going to be in Los Angeles playing at Staples Center,
Right.
or any other place out west.
So Bakersfield went from the ECHL,
Yes.
if I'm not mistaken, right? Which is the one step below AHL, or was there
Yes.
something in between?
Yep, no, ECHL is AA, then you have the AHL, which is AAA, and then the NHL, which is as high
Okay,
as
so
you can go.
Bakersfield moved up a level.
Yes.
Are there other cities that Bakersfield used to play that moved up as well?
Yep, Ontario and Stockton. The Ontario Reign were in our league previously. Stockton's old name was the Stockton Thunder. Now they're called
Right.
the Stockton Heat, and they'll be up in Stockton as well. So it'll be the same building, but a different name.
Because I know there's a lot of support for the Condors in Bakersfield. And I know there are a lot of fans that follow the team when they go on the road.
Absolutely.
So this way they can still go to cities that they've been to before and still see the Condors, even though they're in a different league now.
Even better, too, we added the cities of San Jose and San Diego. So what better excuse to make
Let's
a
go to
weekend
San
of it?
Diego
Let's go to
and
San
head down
Diego
there.
for the weekend. So it's going to be really exciting, and there's 5 teams in California.
So the league, their affiliate is now different, but the scoring is a little different also.
Yeah, the way the playoffs work is a little bit of a tweak this year. And the reason for it is because we're playing 68 games, where the rest of the league, and I say we, the 5 California teams, there's 30 teams total. So 25 teams are playing 76 games, and 5 teams, including us, are playing 68 games. So playoffs used to be easy. You used to tally up your points at the end of the year.
Right.
Whoever had the most points, they took the top 8 teams.
On you go.
You go to the playoffs. Well, this year it's a little different. Where we're playing less games, they have to come, and I actually liked your initial example, was a point percentage. So now we're taking a percentage divided by how many games you played. So for example, we have 68 games this year, so we can get a total of 136 points.
Okay.
You get 2 points for a win, 136 points would be the total. There's not a chance we win all of our games, but
There is a chance.
there is a chance, I
Okay.
suppose. So out of those 68 games, the benchmark, I guess, is a 60% percentage on points.
Okay.
So you need about the 60% percentile to get you into the playoffs.
So you need 60% of 136.
Of 136 points. Now, there's going to be teams that might have more points than us that are playing 76 games, but because they're playing 76 games, their possible points is 162.
Right.
So they have more chances to get more points, but not necessarily a better percentage. So it's going to be, and it's going to take some process, I think, to get fans used to it. You kind of have to disregard the points almost, because if a team who's playing 76 games might have, say, 4 or 5 more points than us, but the percentage for us is a lot better because we're playing fewer games. So technically our wins count a little more
Right.
because we're playing less games.
And somebody looking at the numbers will really get into this.
Oh,
And figure out, all right,
we might
need
have to
this
call in.
exactly to happen. By all means, Tuesdays and Wednesdays before the game. Now, I know you have a lot of other things going on, and we want to talk a little bit about that in
Sure.
a couple of moments. But right now, we're going to go back to the phones. 636-4357 is that phone number. From American Elementary, Lizzie, how are you today?
Good.
And what grade are you in, Lizzie?
5th.
All right, as soon as you're ready, let's hear the math problem you're working on.
Okay, so me and my friend needed help on 9 over 21, and we needed to simplify that.
So 9 over 21, so you're simplifying fractions, right?
Yes.
Okay, so let's look at 9 over 21, and how do you simplify a fraction? So some teachers showed different ways, so how are you going to simplify a fraction? Can you tell me?
I really don't know.
Well, you have 2 ways that you can do it, right? And so again, it depends on your teacher or your book. So have you worked with division or have you worked with factors?
Both.
Both? So here's one way you can do this problem. We can write 9 as the product of 2 numbers, right? Can you give me 2 numbers that multiply to 9?
I see.
Lizzie?
What's that?
Lizzie, can you give me two numbers that multiply to 9? What times what is 9?
9 times 1.
9 times 1, okay. Can you give me two other numbers that multiply to 9?
3 times 3.
So how about 3 times 3? So we can write 9 as 3 times 3, can't we? How about two numbers that multiply to 21?
What?
Two numbers that multiply to 21. That's our bottom number, right?
Yeah. 7 times 3.
Okay, so 7 times 3. That's 21. And now what we're going to do is we're going to reduce this fraction by doing some simple, really simple division. And here's the simple division. What's 3 divided by 3?
1.
It's just 1. So 3 divided by 3 is just 1, isn't it?
Mm-hmm.
And so they divide out and they become 1. And so what's left is a 3 on top and a 7 on the bottom. So 9 over 21 is equal to 3 over 7. So that's one way of reducing those fractions. Okay?
Okay.
Right?
Nicely done,
That's the
Lizzie.
problem.
Are you ready for another one?
Yeah.
You want to do another one?
Yes.
Do you have one on your homework, or would you like me to think of one for you?
We have one on our homework.
Oh.
Okay.
I was going to give you one, but if you have one on your homework, let's hear that
So
one.
give me another problem.
5 over 20.
5
That's
over
close. I was going to give her
20.
5 over 25. Is that what it is?
I'm sorry, Lizzie, 5 over 20?
Yes.
Yes, okay, so 5 over 20. All right, now, do you want to do it that same way, or do you want me to show you another way of doing this? Let me show you the other way, okay?
Okay.
All right, so we broke it up into factors, into two numbers that multiply to 5 and 20. Can you give me a number that will divide into both 5 and 20? So you may have done this. I'm looking for the greatest common, I'm looking for the greatest common factor, okay?
Okay.
So what will
So-
go into both 5 and 20? So let's look at some numbers. Does 2 divide into 5 and 20?
Mm-hmm.
Lizzie, does 2 divide into 5?
I can't hear you.
Can you not hear me okay? Okay. Lizzie, can you hear me? Can 2 divide into 5 evenly?
No.
No. Does 3 divide into 5 and 20? No, 3 doesn't go into 5 either,
No.
does it? How about 4? Does 4 go
No.
into 5? No. How about 5?
Yes.
Does 5 divide into 5? It does. Does 5 divide into 20? It does, doesn't it?
Mm-hmm.
So what we can do in this problem, instead of using these factors, we'll do a division. I'm going to divide the top by 5. I'm going to divide the bottom by 5.
Okay.
And we're going to end up with a new fraction. What's 5 divided by 5?
1.
1. And what's 20 divided by 5? So what's 20 divided by 5, right? 5 times what is 20?
4.
4. So 5 times 4 gives me 20, doesn't it? So I know that 20 divided by 5 is 4. And once I get that 1 on top, I know that I can't divide that anymore, can I? And so this fraction works out to be 1/4. Okay?
Nicely done, and for doing such wonderful work on that, we're going to send you to the Kern County Fair. So we hope you have fun out there. 636-4357 is the phone number. We do have phone tutors available until 5:30 on Tuesdays and Wednesdays. The Condors moving into the AHL. We've got Ryan in studio with us. The Teddy Bear Toss is one event that I know that we go to every year.
Yeah, as you should.
Well, I know. And we enjoy that a lot. And there are a lot of other activities and special days that you have throughout the season. What are some of those that are coming up? Maybe ones that you're going to carry over and possibly some new ones.
Yeah, the perfect one for students is Field Trip Day, and that's our early game, I guess, if you will. Early for...
In November, correct?
In November. November the 18th is our Field Trip Day this year. It's a Wednesday. We'll play at 10:30 in the morning. So it's a little bit of an adjustment, but we have 6,000, 7,000 students out. So if you're in your classrooms this week, tell your teacher, hey, I want to go to field trip day, and oh, by the way, let me show up on the school bus. So it's really cool. We really like it every year, just to see the smiles on the kids' faces, and we give them a nutritious lunch at the game. They come on the school buses, 7,000 kids. We play all sorts of fun games up on the Jumbotron, and then
I know we'll be out there also.
Exactly, and then we put you back on the bus and send you back to school. So, but it's the best field trip I think I ever had as a kid was going to sporting events. I think I was always passionate about sports.
Because there's not that many opportunities to go, especially during school.
Exactly, and we really enjoyed it, and it's grown each and every year. We had almost 7,000 kids last year. We're hoping to even make it bigger this year. So students, teachers, superintendents, everybody, come on out, and it's a lot of fun. One of the big things we're doing is simply just our opening weekend.
And when is that?
It's next weekend, next Friday and Saturday. It's coming very quick. But it's very cool. It's our first foray into the American Hockey League. So we're giving away sunglasses to pretty much everybody Friday night. And then Saturday night, we mentioned Boston, but we're giving away deflated footballs on Saturday night.
Okay.
So don't worry, though. We don't poke holes in them. You can go home and pump them up. But we have all sorts of sports teams for the footballs, the Seahawks, the Raiders, the 49ers, and the Patriots ones. They're deflated. It's going to be a lot of fun next Friday and Saturday. And I'm looking forward to that. We have the Teddy Bear Toss coming up the first Saturday after Thanksgiving this year. So that's an annual tradition that we're carrying over from the ECHL, and we'll do that every year.
So the American Hockey League had no problem scheduling you guys, knowing that was something that you guys do, and it's successful.
Exactly. And they want,
they're able to keep it.
And the AHL as a league wants their teams to be successful. So every January they send out an email that basically says, okay, what are your days that you have to have? What are your traditions that you have to have? And that's the first one that pops up for us. Saturday after Thanksgiving, that has to be Teddy Bear Toss. And it's always the biggest crowd of the year. We get 7,000-8,000 teddy bears out on the ice. It's a whole lot of fun. The guys, the players, they really enjoy it every year. And just seeing all the teddy bears hit the ice. So that's one of our carryover promotions, and we'll have stuff all throughout the year, entertain the kids. I think we're giving away Minions backpack clips during the year too, so you can come out, get a Minions backpack clip. We've got the Kids Club, which you get 6 games for just $10, and that's perfect. You bring the parents out. I mean, we've really kept it family friendly, family affordable. That's what we're all about. We're all about the community and all about bringing the families out, because at the end of the day, that's why we're here, and that's who keeps us around.
That's right. Well, you know what? We certainly were excited to have you guys on board again this year. You guys have been sponsors with Do the Math for a long, long time. And what we do is every day we give away a family 4-pack to the Bakersfield Condors, and this is one of the certificates that students will receive. And you can see how big this is. I mean, it's the size of my hand, all right? But students will receive a family 4-pack of those by calling in, doing a math problem. They're eligible to win this.
That's awesome.
As a matter of fact, we have one of those winners will be on in a little bit on the program. But anyway, Ryan, much success for this coming year with you guys.
We look forward to having you.
And we'll take some more phone calls in a little bit. But turning now to part 3 of our special Do the Science series on water, IDS manager Dave Beard brings back water purification plant superintendent Kelly Ulrich, who drives us. Well, you drive deeper into it. But anyway, that's ID4 manager Dave Beard. Because I remember when we were out there.
That's right.
It's ID4 because they had a big long name and they just call us ID4. But anyway, Kelly Ulrich, this guy is quite the character, and he's going to dive us deeper into the filtration process. Dave, it has certainly been fascinating to watch the flow of the water throughout the purification plant, and I know that the water is coming in, and John, I know we spoke about this a little earlier, but the flock has arrived. We are now able to see the flock and all of the flocking, coagulation and things like that. Dave, you brought Kelly back with us. What is going on up here?
Well, as we saw earlier in the flash mix, the chemicals have been introduced to the raw water, and so a lot of things are happening, and I think the best person with the technical details of that would be Kelly.
So Kelly, we got a lot of water here. What's going on in terms of the filtration process?
Okay, the water, as it left the flash mix, as Dave mentioned, the chemicals were introduced. And then it hits this first stage, we call it flocculation. That's where the flock has already started to develop. And we have 3 different stages, and through each stage there's mixers that gently mix it. They rapidly mix it, and then they slowly get slower and slower, so they don't actually shear off the flock itself, because we're trying to make it as large as possible. After it leaves the flocculation basin, it is then introduced into the sedimentation basin. And the sedimentation basin is where most of the flock particulates settle out, collected with sludge collectors, and that's how they are pulled from the basin to keep the basin from getting plugged up with all the fallen flock. And after the sedimentation basin, we hit the settle water channel. At that point, we introduce our sodium hypochlorite, and that's our primary disinfectant. Right after the settle water channel comes around to our 6 filters. Our filters basically are dual media. They have anthracite on the top, and they have silica sand on the bottom. And each train, this is a treatment train A, there's another treatment train B, has 6 total filters. They're bifurcated, so they're split in half. And so that allows enough of the filtration process where the water can actually be considered safe to drink.
So we're on the way to the water getting to the homes and the customers here in Kern County. Where does it go after these processes?
After filtration, we have storage facilities on site. We call them clear wells. We have one 4.5 million gallon facility, and then we have another 2 facilities that are 3.2 million gallons. So we have a total of about 11 million gallons of storage on site.
All right, so we're with Kelly, and she's going to explain with us the 3 different types of media that go along with the filtration process.
Okay. First of all, as I explained earlier, these are dual media filters that mainly consist of the anthracite, silica sand, and then a small amount of gravel is used for support. First of all, this train B has deep filter beds, 2.5 feet of anthracite, and then directly underneath that is 1 foot of the silica sand. And then directly under that is actually our filter under drain nozzle system. And to support that nozzle system is the gravel. There's approximately 1 foot of gravel down in between those nozzles. And so actually water is filtered down through this media, and then once we have either a certain amount of hours on our filters or a certain amount of turbidity, then the operator makes the determination to backwash a filter. And so this media not only withstands water coming down through it, like via gravity, it also can withstand a backwash of approximately 10,000 gallons per minute coming back up through to wash all the stuff that is collected on top of the filter, washes it off and takes it out to a waste pond.
Interesting. So after the water travels through the different types of media and through the filtration process, then it's ready to drink, right?
Yes. At this point, the sodium hypochlorite, which is our disinfectant, has been added. It then enters the clear wells where it actually have a certain amount of contact time.
And there you have it. That's it. The water traveling through the filtration system from the basin all the way through the plant, and now it's ready to drink.
And are you able to remotely control the chemicals from here?
Everything is remotely controlled. We can do everything from this station you see right here.
All right, do you remember we have phone tutors available until 5:30 on most Tuesdays and Wednesdays throughout the regular school year? That phone number is 636-4357, toll free in outlying areas of Kern County, as well as San Luis Obispo County, 1-866-636-6284. Our newest tutor is on board with us right now. Did you know you're going to be working today?
No.
You would be. All right. This is Jordan, and Jordan, why don't you let everybody know where you go to school and what grade you're in?
I go to Kendrick Elementary, and I am I am in 5th grade.
How's 5th grade going?
It's doing pretty good.
Yeah? What's the best or easiest thing about 5th grade?
History.
History?
Yeah.
Are you guys studying American history?
Yeah.
And you guys will be getting into the Revolution and things like that, or are you already there?
We're gonna get
You're
into
going to get
it.
there. Well,
Yeah.
5th grade is that social studies getting into American history, the American Revolution and stuff is,
Yeah.
I mean, it's pretty cool stuff. I like doing that also when I was working with 5th grade students. Now, you're here. Do you know why you're here?
Yes.
Why?
Because I'm gonna do math problems.
You're going to do some math problems, but you're also here because you phoned in a couple of weeks ago and you needed some help on one of your math problems.
Yeah.
And we helped you out, and then we put you into a drawing, and you won the Condor tickets that day.
Oh.
Right? So you've got
Yeah.
yourself those family 4-pack of the Condors tickets. You just saw Ryan in here, and you have the whole season that you're going to be able to go and check it out because they haven't even played any games yet.
Okay.
Have you been to a Condors game
Yeah.
before? Oh, so you know what they're like.
Yeah.
All right, cool. Well, we hope you have fun out there with the family 4-pack. Let's take a look at some of the problems that you're working on right now. So it says, change the fraction to a decimal using division. Remember that the numerator, top of the fraction, goes inside the division box. Add a decimal and at least 1 0 to divide. Now, the first one that they have there is 3/4 is equal to, and you have a foot, is that what that is?
Yeah, you kick the fraction. You kick the fraction over.
Explain it to me again. So you're kicking what? What are you doing?
You're kicking the 3/4 sideways, and then you turn it into division.
All right, go to the board.
Okay.
I think you're going to kick that numerator, huh?
Yeah.
All right, so write 3/4
3/4.
and explain to us what you're doing.
So you kick it over, and it becomes. Oh. How do you erase it?
So here, you just want to erase this.
Oh.
There you go.
So when you kick it over, you put the 3 outside the house and the 4 inside.
Except, what are you dividing by? Remember, so you're going to kick it over, and the 3 is
Yeah.
going to go here, and that's going to go inside the box. So the 3 is going to go inside, and the 4 is going to be on the outside. So when you kick this over, the 3 goes here. So let's show that. We have the pad. Let's get that here. When you get that, okay. So now kick the 3 over and put the 3 right here. And then make your division box. So there's your division. 4 goes
Yeah.
into 3, okay? So when you say that foot kicks it over, so it falls over and goes inside,
Yeah.
okay? So now, what does it say to do? We have to put a decimal, right? Where's
Make
that
it into a
decimal gonna
decimal.
go? And then it says use at least 1 0, right? But we don't know how many we're going to need until we start doing the problem, right? So let's
Yeah.
go ahead and do the division. What do you get when you divide? Well, 4 doesn't go into 3, does it?
No.
But 4 goes into, and let's see, well, you put the 0, let's go ahead and put the decimal up there too so we don't have to worry about it. Now let's divide 4 into 30. What do you get? So some
28?
Yeah, so you go 4 times
7.
4 times 5, 4 times 6, 4 times 7. So put your 7 up there. And what did you get when you have 4 times 7? So let's see how close you came. So let's go
28.
do the subtraction.
And
Okay, so now it said to add at least 1 0, but in this case we need more because we have something left over. So at least 1 0 means 1 or more. So let's add another one and see what happens.
20.
Okay, now let's divide again.
5.
And how close did we come? Remainder of 0. So as soon as we get that remainder of 0, we know we can stop. So we know that 3/4 is equal to 0.75.
All right, so you can leave that up there. Let's go ahead and write your next fraction next
Okay,
to
let's
that.
Okay.
put the
So the next
right
one
here.
you need to work on is 3/8, 3/8.
3/8. So you're going to kick that 3 over, put that in front of the 8. Right? Yeah, so you can put it, yeah, you got to just make sure here, hold it there so you, that's the
okay.
only thing. There you go. And then divide by 8, right? Okay, so now we've got to put our decimal and put 1 0 and see if that's enough. And let's go ahead and do the division. Put that decimal point up so we don't have to worry about it.
And 30 times.
Good, that's 24. And how close do we come?
Wait. Yeah.
Okay, so we have a remainder. So we know 1 0 wasn't enough, so we're going to put another one and bring that down. And let's divide again. 8 goes into 60 how many times? So again, multiplication facts really come in handy, don't they? 8 times what gets you close to 60? Well, a good place to start would be, what's 8 times 8?
64.
64, which is just a little bit too big, right? So you should try.
8 times 5.
Well, 8
Let's
times
go
8 was pretty close,
Oh.
wasn't it? So let's try what
8
just,
times 7.
what's 8 times 7?
56.
56. So that looks pretty close, doesn't it? So put your 7 up there. And we still have a remainder that's not 0, so now we got to put another 0, don't we? We keep putting them there until it stops, and hopefully it stops, right?
Yeah.
Okay, let's extend this over. I mean, let's make sure we keep things nice and lined up. That 7 was over this 0, so extend that line. Extend that line, so make sure that our next answer is going to go right up here at the end. Okay, so now 8 goes into 40. You had said let's try 5 before.
Yeah.
Well, let's try 5 now. What's 5 times 8?
40.
That's nice. It works out to be a nice round number of 40. And there's our remainder of 0.
Yes.
So it looks like our answer 3/8 is equal to 0.375. So it said in the directions to add at least 1 0,
Yeah.
but you got to keep adding them as long as you need them.
Yeah.
Okay?
All right, nicely done. We're going to give you guys a break right now, Jordan, so
Okay.
come on over. You can leave the pen there. Back to the phones right now. We've got another student from American Elementary. Riley, how are you today? Hello, Riley.
Hi,
What grade are you in?
I am in 5th grade.
All right, as soon as you're ready, let's hear the math problem that you're working on.
Okay. So right now I am working on what multiplication and division problem does this model represent. So there's 1, 2, 3, 6 cards, and then there's 4. And then there's suns inside the cards. 4 suns inside the cards.
So, I'm sorry, did you say cars or cards?
Okay, so what is the multiplication and division problem does this model represent? So there is cards, like playing cards,
Oh, like a playing card? Like a card? Like this, okay?
and then there's 4 sums in there, and it says, which multiplication and division problem does this model represent?
Okay, so we have 4 cards. Did you say 4 of them?
Yeah, not
Okay.
a car, a card.
Cards, okay, like a playing card. And on the card there is a, did you say a sun?
4 suns.
Suns. So each card, you have 4 suns. So I'll draw like this, like a sun, like this. Like a sun, I'll draw like that. Maybe that's better, right? So each card has 4 suns on it, right? Like this?
Yes.
Those are suns, by the way. So I've got 4 of them on each card, right? And so the question is, what multiplication problem does this
Yeah,
represent?
so there's 6 playing cards with 4 suns in each of the 6 playing cards.
6 playing cards. Okay, 1,
Yes,
2,
I
3,
think
4,
there
5.
are 6 playing cards with 4 suns in each of the 6
Okay,
playing
so your picture looks something like that, and these are all suns, right?
cards.
Okay.
Yes, it does.
All right, so one way we could figure out how many suns there are is we could just count them, couldn't we?
Yes.
But the question was, what multiplication problem does this represent?
What multiplication and division problem?
Okay. So let's see. What multiplication problem? If you wanted to know how many suns there are, what could you do? Instead of counting, we could take how many cards?
You could take the 6 cards and then 6 times 4 is 24.
Each card has 4 suns on it, and so you're going to take.
So you would do 6 times 4 equals 24.
So you're going to take those 4 suns 6 times, aren't you?
Yes.
And that's going to give you your problem.
Yes. 6
So-
times 4 equals 24.
So instead of counting those suns, we could do the multiplication, and there should be 24 suns up in those
Yes.
cards, right?
Because 6 times 4 is 24.
Okay, so there's your multiplication problem. You also asked what division problem?
Yes.
Okay, so what division problem is related to this? Well, we've got
6 divided by 24.
well, let's see. What are we starting
Well, it
with?
sounds like maybe she has options to choose from. Do you have options to choose from, like an A, B, C, D or something like that?
Is it multiple choice?
Or do you just have to come up with it?
Oh, you have to come up with it.
Okay. So how many suns do we have here altogether?
There's 4 suns. Wait, no.
Altogether, we just figured there's 24 suns, didn't we?
24.
So we're going to start with the 24.
Yes.
And what did we do with those 24 suns? We put 4 on each card, didn't we?
So 24 divided by 4
So you could take 24 and divide it by 4, right? And
equals 6.
And that's going to give you the number of cards that we have, doesn't it?
Yes.
But there's another division problem here, isn't there?
Yes.
We could take those 24 suns and we could say, we've got 6 cards, don't we?
Yes.
How many suns are on each card? So 24 divided by 6 is going to give you
4.
same 3 numbers, right? Same
Yes.
3 numbers, 6 and 4 and 24. And here we have 6
No.
and 4 and 24.
Yes. 24 divided by 4.
So we could have 24 divided by 4 is 6, or we could have 24 divided by 6 is 4. And that looks like those are your choices. Great.
All
Great
right,
problem.
nicely done right there, Riley. And for such a wonderful problem, we're going to send you as well to the Kern County Fair. We're sending everybody to the fair. Have you been to the fair yet this year?
This year, no.
Not this year? Well, you're going to go to the Condors, we know that.
Yeah.
And we're going to find out who else is going to go to the Condors because you're going to pick out the name for later on.
Okay.
All right, that's part of your duty today. All right? But before you do that, you have more work to do.
Yes.
You ready? Mm-hmm. Back to the board, young man.
Okay. Last 2 problems?
Well, the 2 problems that we'll work on right now. We'll see
Okay.
how fast you can do these. We may get some other ones done.
Okay.
3 over 5.
3.
Now, I want you to explain to Chuck how to do the problem.
So now,
Okay, so first you kick it over and you put the 3 inside the house and the 5 outside the house. Then you change the 3 into a decimal. So then you divide 5 into 3, which you can't do it. It becomes a 0. Bring the decimal straight up. Then 5 into 30 is 6. You multiply it, it comes 30. Subtract, it comes 0.
and this time you're lucky. 1 0 gave you a 0 remainder, so you're done. 0.6 is your
Yep.
answer.
All right, now you have
good.
one more of those problems on this paper that you brought in, and it's 1 over 4, 1/4.
Okay, last one. Let's do this one.
So you kick over the 1/4, 1 inside the house, 4 outside the house, change the 1 into a decimal. 4, you bring the decimal straight up. 4 divided by 1, you can't do it, so you make it 0. Then 4 into 10, it only goes up to 2, which is 8. Then you subtract, equals 2. So then you have a remainder, you add another 0, you bring down the 0, it becomes 20. So then you divide 4 into 20, which is 5. Then 5 times 4 equals 20. So you subtract, and your answer is 0.
There you go.
And there's your answer.
Nicely done. So go ahead, erase the board. I'm going to have you boys work on one other problem. Now, Jordan, I was looking at your math packet here, and I turned the page, and I don't know if you started working on these or not, but you're going to work on the first one today.
Okay.
All right? We're going to do some prime factorization using the tree. Have you done these in class,
Yes.
or is this something you're going to come up to?
We've done this in class.
You've done this?
Good.
All right. So let's go ahead and factor 32.
Okay, so 32, we're going to do
And Chuck, we're going to give you guys about 3 minutes to work on this.
okay, so a factor tree. So you're
Yes.
going to make the branches, right? So make 2 branches. Well, except we're going to make
Oh,
branches like this,
okay.
right? So here, let me get this. So we're going to branch it and make our tree coming down like this. So make an upside down V. No,
Oh,
make a
sorry.
V here, and then go down like this. So start in the middle, and just go down to one side and then down the other side. So there's the branches of your tree, okay? Now, can you give me 2 numbers that multiply to 32? Well, since you know it's an even number, you could do it by 2, but on your multiplication table, you know 2 numbers that multiply to 32. What 2 numbers give you 32 on your multiplication table?
8.
8 times? You know 8 times
8 times
3?
4.
Yeah, so you knew that 8 times 3 was 24 because we used that before. So this is 8 times 4, right? You put an 8 there and a 4 there, okay? All right, now we got to break those up, right? Can we break down 8 and 4? So do the same
Yeah.
thing. Put that upside down V there. Can you give me 2 numbers that multiply to 8?
4 times 2.
4 times 2. So put your 4 and your 2. Okay? Now, can you break down the 4 anymore?
Yes.
Yeah, so you put another V there, upside down V, and break that up.
2 times
And
2.
can you break down the 2?
No.
No. Can you break down this 2? No, we couldn't. Let me put that 2 back in there here. So once we get down to the 2, we know that those don't break down anymore. Do you remember what those numbers are called? When you get to a number where you can't break it down anymore,
No.
I mean, it's just 1 times 2. Those are prime numbers.
Oh, yeah.
So we can't do it anymore, so we stop there. But now let's go up to that 4. Can you break down the 4? And we got 2 more prime
2.
numbers. So we're going to write up here 32 equals, and let's see what it equals. It's 2 times 2 times 2 times 2 times 2. So we can write that up there, the prime factorization, and just write down all of these 2's. 2 up here, 2 times 2 times 2 times 2, and 1 more times 2. So we know that 1, 2, 3, 4, 5 2's multiply together to give 32.
And let's go ahead and put 2 to the 5th.
Yeah.
And we know
There you
that
go.
that's 5 factors of 2, so we use the exponents to write 2 to the 5th power. And we're
All right.
done.
Nicely done. Come on over here, young man. You've done some fine work today. We know you're going to the Condors, but you are now the newest ambassador for Do the Math. Do you know what that means?
No.
It means you have to wear this shirt every single day, only when you go to school.
Okay.
Okay, you don't have to wear it on the weekends.
Okay.
You can wear it occasionally if you need to wash it every once in a while, all right?
Okay.
And just tell other kids about Do the Math. Can you do that?
Yeah.
Easy enough. You know what? You're going to the Condors, and we need you to pick out one of the names from the callers today to see who else is going to the Condors.
Pick a card.
All right?
What do you got?
Riley.
Riley from American Elementary. I think that was the last student that phoned in today, so congratulations to Riley. That'd be funny if you guys showed up at the same time with your Do the Math shirts on. Wear your Do the Math shirt to the Condors game, so if we're there, we can find you.
Okay.
All right? Until we meet again, continue to do the math.
Major support for Do the Math has been provided by Chevron, the Kern County Superintendent of Schools, California Resources Corporation, Kern County Water Agency, Kern Schools Federal Credit Union, Panama Buena Vista Union School District, and Bakersfield City School District, with additional production assistance provided by these supporters of education in Kern County and throughout the state of California.